Applications of industrial boilers. So far, we've covered what a boiler is, along with the different ways industrial boilers are classified by fuel type, combustion technology, and boiler design. Now let's move on to one of the most interesting topics. How are industrial boilers used in industry? Steam is used in countless industrial applications. Wherever heat is needed, a boiler can usually provide the solution. But in industrial applications, steam does much more than simply provide heat. It helps increase productivity, improve product consistency, shorten production time, reduce fuel consumption, lower labor costs, and create a competitive advantage for manufacturers. Let's explore these applications one by one. Application 1. Steam cooking and food processing. One of the simplest and most familiar uses of steam is cooking food and processing products. In the food industry, steam generated by an industrial boiler can be supplied directly to steamers to cook products such as steam buns, fish, shrimp, vegetables, rice, packaged foods, and many other products. With a continuous steam supply from the boiler, the cooking process becomes much faster. When the steamer is a sealed pressure vessel, the steam temperature rises well above 100 degrees Celsius. At atmospheric pressure, saturated steam is approximately 100 degrees Celsius. At around 1 bar, the steam temperature increases to about 120 degrees Celsius. At 3 bar, it reaches approximately 143.6 degrees Celsius. At 5 bar, the steam temperature rises to roughly 159 degrees Celsius. The higher the pressure, the higher the steam temperature, and the higher the temperature, the faster products can be cooked. That's why industrial steamers, sterilizers, UHT systems, and many other food processing equipment rely on steam. Compared with direct heating using gas burners, electric heaters, or open flames, steam provides more uniform heat distribution, better temperature control, and shorter processing times. Application 2. Product drying. Another very common industrial application of steam is product drying. Steam flows through heat exchanger coils. A blower forces air across these coils. As the air passes through, it absorbs heat and reaches the required temperature, whether that's 80 degrees Celsius, 100 degrees Celsius, 150 degrees Celsius, or higher depending on the system design. The heated air is then blown through the product, causing moisture to evaporate. As a result, drying can be completed in just a few hours, instead of relying on natural sunlight for several days. Today, a large number of industrial steam applications are related to drying processes. Examples include drying rubber products, rice, agricultural crops, food products, incense sticks, gloves, fabrics, paper, packaging materials, and many other industrial products. Steam-based drying is also an effective way for factories to reduce production costs. In the past, many conventional drying systems used diesel, LPG, or natural gas burners to heat air directly. The hot combustion gases were mixed with air and then blown directly into the drying chamber. The biggest drawback of this approach is its high fuel cost. In addition, direct contact between combustion gases and the product can affect its color, odor, cleanliness, and overall quality. At DIVI, we've completed many projects converting drying systems from direct-fired oil or gas heating to steam-heated air generated by biomass-fired boilers. Biomass fuels such as wood chips, rice husks, sawdust, bark, wood pellets, cashew shells, and palm shells are significantly less expensive than oil or gas. As a result, drying costs can be reduced dramatically. In Vietnam, many rubber drying plants have already adopted this solution, with fuel cost savings of more than 50% in many cases. Beyond lower operating costs, the finished products are often cleaner, more consistent, and of higher quality. This is a great example of how a boiler is much more than a steam generator. It is a valuable production asset that helps manufacturers increase profitability by reducing operating costs and improving product quality. Application 3. Heating water and liquid solutions. The third application is using steam to heat water and various liquid solutions. Think about a traditional cooking process. Whether it's water, chili sauce, seasonings, fermented mash, or another liquid, the pot is typically heated from underneath using wood, gas, or oil. Heat is transferred directly from the flame to the bottom of the vessel. This method has several disadvantages. First, it takes a long time to heat up. Boiling water or a processed solution can take 30 minutes, 60 minutes, or longer, depending on the tank size and heat input. Second, the heat distribution is uneven. The bottom of the vessel becomes much hotter than the rest. Without proper control, the product may burn, scorch, form deposits, or suffer from quality issues. Third, low productivity and heavy reliance on manual labor. Switching to steam heating changes the process completely. Instead of heating the pot directly, we use a double-jacketed kettle. The product remains inside the inner vessel. Between the two walls is a steam jacket. Steam flows into this jacket, transferring heat indirectly to the product. Because steam surrounds the vessel, the heat transfer area is much larger and the temperature is more uniform, resulting in faster and more even heating. To bring a 200, 300, or 500-liter vessel to a boil, steam at 3 to 5 bar can reduce the heating time to just a few minutes, or around 10 to 15 minutes, depending on the system design. Besides saving time, steam heating provides stable temperature control, prevents scorching, improves product quality, and shortens the overall production cycle. This method is widely used in alcohol distillation, herbal extraction, chili sauce seasoning, tofu making, tofu skin, and many other food processing industries. Anyone who has switched from direct-fired cooking to steam heating can immediately notice the difference. Productivity increases, product quality becomes more consistent, labor costs decrease, fuel costs are reduced, and production time becomes much shorter. These are the practical benefits that an industrial boiler can deliver. Application 4. Solution concentration. Building on the same heating principle, steam is also widely used for solution concentration. Concentration is the process of removing water from a solution to increase its concentration. Typical applications include concentrating sugarcane juice, coffee extract, fruit juice, herbal extracts, edible oils, and many other liquids used in the food and chemical industries. The principle is straightforward. Steam supplies heat to the evaporator. As the solution is heated, water evaporates, leaving behind a more concentrated product. However, evaporation is more than just boiling. Some products can lose their aroma, color, vitamins, nutrients, or overall quality when exposed to excessive temperatures. That's why vacuum evaporation is commonly used for many products. Creating a vacuum lowers the pressure inside the equipment. Water boils at a lower temperature as pressure drops. This allows the solution to boil at temperatures well below 100 degrees Celsius. Depending on the vacuum level, boiling may occur at 70 degrees Celsius, 60 degrees Celsius, or even 50 degrees Celsius. This helps preserve product quality much more effectively. Steam itself can also be used to create that vacuum through a device known as a steam ejector or a ventry system. We'll take a closer look at this principle in the next application. Application 5. Steam for mechanical power and electricity generation. High-pressure steam contains a tremendous amount of energy. When high-pressure steam expands into a lower-pressure environment, it expands rapidly and generates a powerful driving force. This is the fundamental principle behind steam turbines used for power generation. In power plants, boilers produce steam at extremely high pressure and temperature. The steam is then directed into a steam turbine. As it flows through the turbine blades, it expands and spins the turbine. The turbine drives a generator, producing electricity. This is one of the largest applications of boilers in the energy industry. In most industrial plants, steam turbines are much less common than steaming, drying, and heating applications. Nevertheless, boilers remain the heart of thermal power plants, biomass power plants, waste-to-energy facilities, and combined heat and power systems. Application 6. Creating vacuum with steam ejectors or ventry systems. As steam flows through a pipe at high speed, it carries a tremendous amount of kinetic energy. With the proper equipment design, this high-speed steam flow can create a low-pressure zone that draws air or vapor from another space. These devices are commonly known as steam ejectors or ventry systems. A steam ejector uses a high-velocity steam or gas stream to create suction. A ventry works by accelerating the fluid through a narrow section, creating a low-pressure region. This suction effect can be used to create a vacuum inside equipment or enclosed process vessels. Once a vacuum is created, the boiling point of the liquid inside the vessel decreases. As mentioned in the previous section, a properly designed vacuum system allows certain liquids to boil at 70 degrees Celsius, 60 degrees Celsius, or even 50 degrees Celsius instead of 100 degrees Celsius. This is especially important in the food, pharmaceutical, herbal, fruit juice, and coffee industries, where preserving vitamins, nutrients, aroma, and color is essential. Excessive heat can damage or destroy many valuable components in the product. Vacuum evaporation removes water at much lower temperatures, helping maintain superior product quality. This is one of steam's most valuable applications, yet it's often overlooked. Application 7. Thermal oil heaters alongside steam boilers. Alongside steam boilers, another important industrial heating technology is the thermal oil heater. Like a boiler, a thermal oil heater is designed to provide heat for industrial processes. The difference is that instead of using water and steam as the heat transfer medium, it uses thermal oil. So why use a thermal oil heater? Because producing higher steam temperatures requires much higher operating pressures. For example, achieving steam temperatures of 180 degrees Celsius, 200 degrees Celsius, 250 degrees Celsius, or even 300 degrees Celsius requires a significant increase in steam pressure. Higher pressure means stricter equipment design requirements, greater safety risks, and higher investment costs. In contrast, thermal oil can be heated to 250 degrees Celsius, 280 degrees Celsius, or even 300 degrees Celsius, while operating at relatively low pressure. This makes thermal oil heaters ideal for production lines that require high temperatures without the need for high-pressure steam. Common applications include plywood production, hot pressing, shoe sole molding, mold heating, high-temperature drying, oil and chemical heating, distillation, and many other industrial processes. In hot pressing applications, maintaining a high and stable surface temperature is essential. A thermal oil heater is well suited to meet this requirement. Therefore, industrial heating systems involve more than just steam boilers and saturated steam. They also include thermal oil heaters, hot water boilers, and other heat transfer systems. The right solution depends on the required temperature, operating pressure, heat transfer medium, and the manufacturing process. And these are just some of the many ways steam is used throughout modern industry. It's impossible to cover every application of steam in a single video, but I hope these examples give you a clearer picture of its importance. A boiler is much more than just a steam generator. It is an energy system that provides the thermal power needed for industrial production. Steam can be used for cooking, drying, heating, concentration, power generation, vacuum creation, and countless other industrial applications. Because steam serves so many industrial purposes, choosing the right boiler technology, selecting the right fuel, and operating the system correctly can significantly reduce production costs. That concludes today's video from DIVI Group. We hope you found it informative and useful. Thank you for watching, and we'll see you in the next video.